Hello everyone. In this video we're going to be solving an exponential equation. We have 2 to the power x over 2 equals x, and we're going to be solving for x values. So first of all, we're going to solve this problem, and then we're going to be looking at a result from Wolfram Alpha, and at the end I'm going to show you a graph. So first of all, I want you to notice that we have a power of 2 on the left hand side. And as you know, for real x values, 2 to the power x over 2 is always greater than 0. This implies that x is greater than 0. So we're only interested in positive values of x. So under these conditions, we can go ahead and take this equation and raise both sides to the power 2, because we want to get rid of the 2 in the denominator. So let's go ahead and raise both sides to the second power. And the 2 is going to cancel out because exponents are multiplied. And this gives us 2 to the power x equals x squared. By the way, I did make a video on this a while ago. You can also go ahead and check that out here. Okay, so we have this equation with the condition x is greater than 0. So we're only going to be looking at positive values of x. So how do you solve this equation? Since we have some variables in the exponent, let's go ahead and natural log both sides. Now, this means we can move the exponents. And that gives us x ln 2 equals 2 ln x. Great. Now, to make it more meaningful, let's go ahead and put the x's together. So divide by x and divide by 2, or divide by 2x, in other words. If you do that, divide by 2x, 2 is going to cancel out here, and x is going to cancel out here, and we end up with ln x over x equals ln 2 over 2. So this is the type of one-to-one correspondence that I'm trying to get, and this kind of means x equals 2 works, right? Because if x is equal to 2, then this equation is true. That doesn't mean x equals 2 is the only solution. It just means that x equals 2 is a solution. Now, are there any other solutions? Is that it? Okay, so here's what I want you to notice. So if you have ln 2 over 2, you can go ahead and multiply the top and the bottom by another 2. So you can basically multiply by 2 here and multiply by 2 here. So this becomes 2 ln 2 over 4. But this 2 can be a power, and this becomes ln 2 squared over 4, and that is ln 4 over 4. Now what does that tell you? It tells you that ln 2 over 2 is equal to ln 4 over 4. And you can always check this with a calculator. This just means ln 4 is 2 times ln 2, and which is true. But can we just keep doing this? Like, how about I start off with ln 2 over 2, and then multiply by 3, and then this becomes ln 8 over 6. Unfortunately, 8 and 6 are different, so this doesn't work. If you use the fourth powers, let's go ahead and multiply by 4, because 4 is a power of 2, so that's more possible, right? But this gives us ln 2 to the 4th, which is 16, divided by 8. Again, these numbers do not match, and you're going to notice that the top number is always going to be greater, because in one case you're kind of raising 2 to that power, and at the bottom you're basically just multiplying 2 by that number, and as you know, 2 to the n is always going to be greater after a certain value of n. So this is not going to happen again. That's it. We only got another solution. So now what we have is ln x over x equals ln 2 over 2, and that equals ln 4 over 4. If you check the other video, then you'll notice that I gave you a graph of ln x over x, which you kind of look at. So from here we get another solution, which is x equals 4. So along with the 2, we have 2 solutions, and are those the only solutions that we have? So far we got 2 and 4, and remember we were looking for positive solutions, so both of these are good solutions. Now how do we check for other solutions? Well, this is when we wanted to use, it would be helpful to use the graph. So what are we graphing here? Don't get me wrong, we're not using 2 to the power x equals x squared, because that's going to give you a different scenario, and you'll see it in the other video. Rather, we're going to be using the original equation, 2 to the power x over 2 equals x. Now one of these is exponential, and it's increasing, as you should know, right? Even though there's an x over 2, it doesn't matter. It just means square root of 2 to the power x. So we could also write this equation like that. And this would mean that we have a base that is greater than 1, which means our exponential function is going to be increasing. And on the other side, we do have a linear function, which will be a straight line when graphed. So they should intersect at how many points, right? They could be tangent, they could not be, they may not be intersecting, or they'll intersect at 2 points. That's impossible for them to intersect at more than 2, because let's take a look at the graph, and hopefully the graph will give you a better idea. But before we take a look at the graph, I want to show you another thing that uses Lambert's W function. I know some of you are a big fan, so I just wanted to briefly mention that, and hopefully I'll leave some questions with this, because when I calculated it and on Wolfram Alpha, I got an interesting result. I'll share that with you as well. So now I want to hold on to the x here, so let's go ahead and divide both sides by 2 to the power x over 2. And this is going to give us x times 2 to the power negative x over 2. I want to write this with a negative exponent, and from here I'm getting 1. So this is equal to 1. So now we got this equation, x times 2 to the power negative x over 2 equals 1. Now I want to get a value like a times e to the power a, so I can use the Lambert's W, because as you know, this is equal to a under certain conditions, right? So what am I supposed to do? First of all, I do need e in the base, so let's go ahead and write 2 as e to the power ln 2, right? Any number can be written as e to the power ln that number. So let's go ahead and replace the 2 with that. We get x times e to the power ln 2 to the power negative x over 2 equals 1. So far I haven't multiplied by anything, I just wrote this instead of the 2. Now we're going to multiply the exponents, so I can kind of write it as x times e to the power negative x over 2 times ln 2. I want to write the x term first, equals 1. Now notice that I'm kind of getting closer to this pattern, a times e to the a. The only problem is the exponent of e doesn't match with this term. So I kind of need to multiply both sides by something, but that can be done because I have a negative x over 2, which means I need to multiply by negative 1/2 and also by ln 2. So in other words, we're going to multiply both sides by negative 1/2 ln 2. Let's do it. Negative 1/2 times ln 2, multiply here and multiply here. Okay? So that's going to give us the following, and our rule for alpha is coming up. We're going to get x multiplied by negative 1/2 is negative x over 2 ln 2, and that is times e to the power negative x over 2 ln 2. As you can see, this is like a times e to the a. So on the right hand side, I have negative ln 2 over 2, which you can also write as 1/2 times ln 1/2. Anyways, so from here you can use Wolfram alpha, not Wolfram alpha, what's that called? Lambert's W on both sides, and hopefully you're going to get something interesting from here, right? This should give you the solutions. But the problem is when you evaluate this in Wolfram alpha, you get a negative answer for this one. Why is that happening? Something to think about. Let's go ahead and take a look at the graph and we'll just finish up. So here's the graph. As I told you earlier, we have an exponential function and a linear function. They intersect at 2 points, x equals 2 and x equals 4. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.